We'll look at exercise number 3 from the set of week 4 exercises. And we are using the dataset ICU-original cvs.csv that you can find in the Canvas folder. Okay, this data comes from patients that were admitted to ICU, and we'll be interested in modeling the discharge status, STA, alive or deceased. So the question number 3 asks us to fit a model for the probability of not surviving to ICU. So we want to fit a logistic regression using a fractional polynomial for the variable systolic, and then to plot the fractional polynomial and compare it with a linear association. So we'll open Stata. We're going to import the data. We've done this before, so I'll assume that you know how to do this. So I'll import the data, and I'll fit the fractional polynomials of dimension 2, and the idea is that I want to compare it with fractional polynomials of dimension 1 and also with the linear model. Okay, so I'll use the command fractional polynomials that you find in the linear models. Again, this is a bit strange given that we want to run a logistic regression, but this is where the fractional polynomial command is in the menus. So I'm going to select fractional polynomial regression, and I'm going to say that I want a fractional polynomial for the variable c's, and the command that I want to run is a logistic regression for the variable STA with c's systolic variable between the less and more than symbols, and state is going to fit a fractional polynomial of degree 2. In the same output, we're going to see the result for dimension 1, so FP1, and also for the linear model. So I'm going to do run. So it's fitting all the models, and the best fractional polynomial of degree 2 is here at the bottom. This is the one that actually was fitted by Stata in the output here. Okay, the powers are 0.5 and 3, so it's using transformation for the variables systolic of square root of systolic and systolic cube, or systolic to the power of 3. And now we will want to compare this with FP1 and also with the linear model. And we can do this with basically 3 criteria. With this hypothesis test that's presented in the result, that compares all these models with the reference model that is the FP2. Okay, we can also use the AIC criteria or the BIC criteria. Okay, so we have 3 ways of deciding which model we want to choose. Okay, so let's start here with hypothesis test criteria, and what this result shows me is the comparison between FP1, so fractional polynomial of degree 1, with fractional polynomial of degree 2. And the null hypothesis is that both models are equivalent in terms of deviance. So I have a high value for the p-value, which means that there's no evidence that M2 is superior to M1 or FP2 is superior to FP1 in terms of deviance. Okay, the data does not reject the null hypothesis, so there's no evidence against it. So I'll accept that the 2 models are equivalent in terms of deviance, and because they are equivalent, I will probably choose the FP1 given that it's less complex. Okay, so this would be the first criteria to use, and if I would stick to it now, I would like to compare FP1 with the linear model. So I know that FP1, I don't need to go one step further to the FP2. FP1 maybe it's enough, but I would like to compare FP1 with the linear model, and I don't have that test here because this test corresponds to the linear model compared to the FP2. Okay, so if I'll stay with this criteria for now, and I'll come back to the other one. So what I want to do is to rerun the fractional polynomial. So fractional polynomials here, but now I'll restrict that the maximum dimension of the fractional polynomial is 1. And if I run straight away, I'll get an error. Okay, and the reason for that is that the auxiliary variables that are created for the fractional polynomials were already created in the previous command. So actually, I have to run the new fractional polynomial command with added replace, so the variables that were created before are replaced. Okay, so exactly the same thing, but with replace added to the command, and if I rerun this, it should be fine. Okay, so I have here the result for FP1, and using the same criteria, I'm now comparing FP1 with the linear model, and what this p-value tells me, which is a bit low, is that the data provides evidence against the null hypothesis, meaning that the data provides evidence against the two models being the same, and this is the same thing as saying that M1 seems to fit better than the linear model, okay? Because this is small. So the model, according to this criteria, the model with 1 over systolic, that's what this power means of -1, would fit better than the linear model, okay? So this would be the first criteria, and here would be the final model with the effect of systolic. And you can see that the odds ratio is humongous, and this most likely is due to the unit used for systolic. We're not really interested in interpreting this for now. We're just looking at the exercise from the point of view of selecting the model. Okay, so if I prefer to use AIC or the BIC criteria, what I had to do was I'll start again with the same command. So I'm fitting a dimension 2 polynomial, fractional polynomial, to the model. I have to add now the replace, again for the same reason, because the auxiliary variables were created. So I'm running the FP2, so I get the result as above, right? So this was the result that I had above. And I can now ask for the AIC of this model with the command stat IC. Okay, this will give me the AIC and BIC for the last model fitted, which is going to be the FP2. I'm going to run this. Okay, so I have here the AIC and BIC, and I'm going to produce the 3 BICs for FP2, which is this one. I'm going to do this for the FP1, so I'm going to run the fractional polynomial with the dimension 1 here. Cannot forget to put replace. So FP just with the 1 dimension, and I'm going to ask for the AIC of this model, stat IC, and I'm going to run the linear effect model. So the logistic for stay with systolic as a linear effect, and I'll ask the AIC for this model again. Okay. So I now can compare the 3 AICs of the different models. And the linear one is the one with the higher AIC, so it's the one that fits worse to the data. And then I have FP2 here and FP1 here. FP2 actually it's a bit smaller, but virtually the same thing as FP1. There's less than 1 point of difference between the two models. So basically this is saying that they are very similar, equivalent in terms of fitting. I would probably, given this result, I'll probably stay with the FP1 because the model is more parsimonious than the FP2. If we go to the criteria of BIC, again, the linear model will have the higher BIC, so this is the worst model according to this criteria, and the FP1 is the best one. And the reason for this, again, is BIC penalizes, has a heavier penalization for the complexity of the model, and that's why the FP1 wins with the BIC. Okay, so basically all the criteria, except for the IIC, that it's a bit dubious because the lower IIC is in fact the FP2, but given all these results, I'll probably stay with or choose the systolic with the fractional polynomial transformation of power -1. So this is fitting the model with 1 over the systolic. And as I said before, this is the result, and the units here is the units of 1 over systolic, and again this is the reason why the odds ratio it's not really interpretable. Okay, so I should say something a little bit more about this, because when you have the odds ratio with the linear effect model, so this is in fact how much the odds increases per unit of systolic. Okay. In this case, this is how much the odds increases per unit of 1 over systolic, which is meaningless, right? And in fact, if we want to come back to the unit of systolic, we know that the effect it's non-linear, so I cannot have one single odds ratio that describes the association between systolic and the probability of being discharged death. Exactly, because the effect is non-linear. Okay. Last part of the exercise asks us to plot the fractional polynomial and compare it to the linear association. So I'm going to plot the FP1 because that's the fractional polynomial that we end up choosing, and I'll compare this with the predictions from a model with the linear effect of systolic. Okay, so I'm going actually to clear these. You can clear the results just to have clean output, and I'm going to clear this as well. And I'm going to so rerun the FP1, the fractional polynomial. I have it here, so I'm just going to rerun this little bit. So this is the last model that is loaded, the FP1. And now I'm going to store the predictions from this model, okay? And I can do this by coming here. If you already know the command, you can use it directly, or just come here to predictions, and we want to predict probability. So we want to predict what, make predictions from the model in terms of probability of dying. And I'm going to do launch, and the new variable is STA. This is the outcome underscore pred of the predicted, and let's call it FP1 from this model of fractional polynomial 1. Okay, so this is run, and now I'll run the linear model. So it's just not logistic regression with a linear effect, to be more precise in terms of what I'm running. So logistic STA with systolic, and I'm going to ask again the prediction from now this last model, which is prediction, let's call it STA underscore pred underscore lean or linear comma p. Okay, so I've stored in this new variable the predictions from the linear model, and now I just have to plot these two things. So I can do two-way bar. I can I'll start by plotting STA, sorry, STA, variable STA, and the X variable is going to be the systolic. So this will produce just the scatter plot. It's not very useful, but I'm going to add a new plot that is going to be the predictions of the FP1, and the x-axis is going to be the systolic. I can actually write this. So you see here the predictions from the FP1. Okay. If you want to connect these lines, it's important to sort the data set by the variable systolic, otherwise the lines will be connected in a random order to different points. So actually we can sort the data set by C's, so just writing sort C's, and we can, instead of using the scatter, I'm going to put the line. So if I do submit, I'll get the line connected. Okay, and I'm going to add finally the third plot, which also can be a line, but the prediction from the linear model versus systolic. And it can be a line because it's already sorted by systolic, so there's no problem. Better get right variable and accept and submit. And here we go. Okay, so this would be the predictive effect of systolic with the linear model, and you can see here with the FP1. It might be fitting better than the data. So the big difference is going to be really in the low values of the systolic. And that's it for exercise number 3.